All right. Hello, kiddos. This is going to be your test review since my daughter's out sick today. You need to watch this thing all the way through, and you need to be putting these problems on a piece of notebook paper. That notebook paper will be your ticket for the test. So you have to watch this whole thing, put these problems on a piece of notebook paper as we're working through them, and then you can retest. All right. So the first one here, it says solve for the perimeter. So the key word is the perimeter here of both figures. Now remember that the perimeter ratio, the perimeter A and the perimeter B is the same thing as the side ratio. So we're going to first label our figures here. So the small one's figure A, the large one's figure B. And my ratio, remember, is always going to be A to B. So let's go ahead and set this up. So this is my tall side here. So I'm going to use 3 here. And my corresponding side of my triangle is this guy right here. So I'm going to set my ratio up A to B. So remember, we're going A to B. So my ratio, A, is 3. And the corresponding side for B is 9. Now I need the perimeter. Because remember, the perimeter of triangle A is similar to the perimeter of triangle B. So I'm going to take the perimeter of A is equal to 3 plus 4 plus 5. So that is 4 plus 5 is 9 plus 3 is 12. All right, so that's the perimeter of A. Now I don't know the perimeter of B, so that's going to be an X. Now remember, once we get to this, we are going to cross multiply. So I end up with 3x is equal to 9 times 12. Well, 9 times 12 is equal to 108 here. So this is 108, and 3 times x is 3x. From here, I got to get x by itself, so I'm going to divide 3 out. So I end up with x is equal to 36. So the perimeter of A is equal to 12, and the perimeter of B is equal to 36. And this should make sense because my side ratio was 3 to 9, which is 1 to 3, because 3 divided by 9 is 3. So my ratio is 1 to 3. So indeed, 12 times 3 is 36. All right, second one here. Again, we're solving for the perimeter. Well, since this is a rectangle, I know that my opposite sides of my rectangle are the same. So the perimeter, I'm going to call this A, I'm going to call this B. The perimeter of A is 12 plus 12 plus 16 plus 16. And that equals 16 plus 16 plus 12 plus 12 gives me 56. And then I need to use corresponding sides. So let's see, they gave me the long one. So I need to find the long one on A. So my ratio, remember my ratio is always A to B, is going to be 16, that's A, and then B is 8. Well, this is going to simplify down to 2 to 1. So my ratio is 2 to 1, which means our rectangle A is twice as big as rectangle B. Okay, so just like what we did before, we're going to set the perimeter of A, so perimeter A to the perimeter of B. That ratio is the same as my side ratio. So that's 2 to 1. And then I'm going to set this equal to the perimeter of A, which is 56. I don't know the perimeter of B. So here I am, I'm going to cross multiply again. So I've got 2x is equal to 56. Well, I'm solving for x, so I'm going to divide that 2 out. And I'm left with x is equal to 28. So the perimeter of A is equal to 56. And the perimeter of B is equal to 28. And then we can check this again because it says A to B is 2 to 1. So if I take perimeter B, 28 times 2 gives me 56. Or I can go the other way and divide 56 by 2 and get 28. So they both check out. All right, so here, kiddos, anytime I have a composite figure, remember, you need to be looking at the two different figures. I have this one, and then I have the larger one. So when you're setting up your ratios, you've got to keep track of which one's which. And sometimes it helps you if you make sure that you remember that you have to add these side lengths to get the length of B. So our ratio is always A to B. So I'm going to set up my ratio here. So on A, I'm going to start with the length here. So I got X, and then I've got 10. On B, I've got 18, and then I've got 10 plus 5, which equals 15. All right, from here, I am going to cross multiply. So I've got 15x is equal to 10 times 18, which gives me 180, 15x. So to get x by itself, I got to divide by 15. So 180 divided by 15 gives me 12. So x equals 12. So again, on this one, kiddos, you got to make sure you break the triangles apart. And maybe it might help you to actually draw the triangles so that you can split them apart. So you know what their side lengths are, just like what I'm doing here. So this is 18, and this is 10 plus 5. Then it might help you to set up the equations a little bit better. Either way works. All right, again, this one's one of those ones where I have a composite figure here. I got two triangles. I got one triangle here, which I'm going to call A. And then I've got this second triangle here, which I'm going to call B. Now remember, our ratio is always A to B. So I'm going to set up my ratio. I'm going to start with A, and I'm going to start with the base. So I'm going to put 8 and then 6. And then I'm going to go with B. Remember, B, I have to add these guys. So I got 8 plus 32. That's the mistake you guys make all the time. You don't add those two together. And then my height, I have X. All right, 8 plus 32 equals 40. So from here, I'm going to cross multiply. So I end up with 8x is equal to 6 times 4d. So that 8x is equal to 240. And then, again, I got to get x by itself, so I'm going to divide that 8 out. And I got x is equal to 30. All right, next one here. Now I'm just going to check and make sure that all the side lengths they gave me is correct. So I got QP is 9 centimeters. Yep. I got MO is 15. That's this guy over here. I got MN is 15. So that's that guy right there. It says, what is the measure of PR? So it wants this guy right here. So I have to match up my sides. So notice that I go from a right angle. Let me see, where's my... A right angle to 90, or a right angle to angle here, right angle to angle. So those guys are congruent sides, or not congruent, sorry. They are similar sides. And then I'm going to go from the right angle to a straight side, so the right angle to a straight side. So those two are the same side, meaning they're going to be similar. And then I have my hypotenuse, which is pretty easy to find. So now I need to set up my ratio. I'm going to set this guy as A, this guy as B. I'm going to say my ratio from A to B, it's always A to B. So I'm going to set up my ratio then. So I'm going to start with A. I've got 9, and then I'm going to do the hypotenuse. And then we're going to set up B, which is 15, and then the hypotenuse is 15. Alrighty. So from here, we are going to have to cross multiply. When we do that, we got 15x is equal to 9 times 15. Well, 9 times 15 is equal to 135. We got 15x. So I got to get x by itself, so I'm going to divide by 15. I got x is equal to 9. And that should make sense just looking at this triangle. If these guys are similar and that goes from 9 to 15 and that side's 15, then x has to be 9. Because these are the same measurements. These should be the same measurements. All right, moving on to the next one here. I'm going to use my triangle statement. Says I'm started at K, I'm going to L, and then J, and then back. I'm starting at V, I'm going to W, there, and back. All right, so now I can set up my ratio from A to B. Remember, it's always A to B. So I'm going to set up my ratio here. So do A in red. So we're going to start with, we start at K and we go to 25. And then we've got 4x minus 23. So 25 skip 4x. Okay, then let's do B here. So we've got 20, skip 1, and then we've got 2x plus 2. All right, from here, we're going to cross multiply. So I've got 25 times 2x plus 2 is equal to 20 of 4x minus 23. All right, so I got to get rid of the parentheses first. So I'm going to distribute. 25 times 2 is 50x. And then 25 times 2 is 50 is equal to 20 times 4 is 80x minus 20 times 23 is 460. All right, I want to get my x's on both sides, so I'm always going to move my smaller x. And then now my x's are on the right-hand side, so I'm going to move that coefficient to the left-hand side. Cancel that guy out. So now I'm left with 80 plus 50, or 80 plus a negative 50 is 30x. And then 460 plus 50 gives me 510. So I want to get x by itself, so I'm going to divide 30 out. And that gives me 17. And that's, from here, kiddos, you got to check. So I got x. Now I got to go back up to my problem and see what they wanted. They just wanted the value of x. You have to pay attention to whether or not they want x, or if you have to substitute it back in. This one just wants the value of x. Whoa, what happened? All right, here we go. Again, we're going to start with our triangle statement. So it goes P to Q. Oops, I went the wrong way. All right, so it's P to Q, so I'm going this way and then up and back. And I'm starting at T, I'm going to S, then R, and then back. All right, so I'm going to say this is A, I'm going to say this is B. And remember, my ratio is always A to B, so I'm going to set up my ratio. I'm going to put my A in first. So I hit 38 first as I'm walking around my triangle, then I hit 60. My other one, I hit 2x minus 1 first, and then 4x minus 26. All right, from here, I'm going to cross multiply. All right, so we've got 38 times 4x minus 26 is equal to 60 times 2x minus 1. All right, from here, we got to distribute. So we're going to take 38 times 4, gives me 152x. 38 times 26 equals 988, so minus 988 is equal to 60 times 2 is 120x, and 60 times a negative 1 is negative 60. All right, so I'm always going to move my smaller x. And then because my x is on the left-hand side, I'm going to move that 988 to the right. All right, I do that. I end up with 32x is equal to, what's that, 988 minus 60 equals 928. And then I need to get x by itself, so I'm going to divide both sides by 32. And x equals 29. Now, we need to pay attention because this says, once we get x, we need to come up here and read what they want. Well, they want SR. So I need to substitute that back in to SR, which is 2x minus 1. So that means I have to substitute x equals 29 in for 2x minus 1. All right, so 2x, I'm going to substitute 29 for x. Minus 1 is equal to 29 times 2 minus 1 equals 57. Because 29 times 2 is 58. 58 minus 1 is 57. So SR is equal to 57. All right, so let's go to the next one. All right, this is one of those composite triangles again. So we need to make sure that we're paying attention to our triangles. So I've got a small one here, and I've got a large one here. Okay, so this is going to be A, this is going to be B, and remember B, I got to add both those guys. So I'm going to set up my ratio. It's always A to B. Okay, for A, on my side I have 24. And then my other side is x plus 4. And then for B, I've got 24 plus 12, which equals 36. And I've got 2x minus 1. All right, now I got to cross multiply. So I've got 24 times 2x minus 1 is equal to 36 times x plus 4. All right, from here I need to distribute. So 24 times 2 is 48x. 24 times 1 is 24. Distribute here. 36 times x is 36x. And 36 times 4 is 144. Okay, so from here, again, I'm always going to move my smallest x. And then, since my x is on the left, I'm going to have to move that coefficient to the right. So now I've got 12x, because 48 minus 36 is 12. And then 144 plus 24 gives me 168. And I got to get x by itself, so I'm going to divide out that 12. So 168 divided by 12 gives me 14. All right, so again, I've got to go and look at what they want. Well, they want QR. They don't want x equals 14. So I got to find QR. All right, so QR is this guy, so 2x minus 1. So I'm going to say 2x, x equals 14. 14 minus 1. Well, 2 times 14 is 28. 28 minus 1 is 27. So QR is equal to 27. All right, so now I'm going to be looking at my ratios. So I'm going to pick the pointy, so here we go, we got small, and then we got large, got small and large. So I'm going to set up my ratios. I'm going to say A to B. So I got A to B. I've got 15 over 21. Should be equal to 28 over 39.2. Now remember, since we have a decimal, we got to convert these guys to decimals. So 15 divided by 21 gives me 0.71. And then 28 divided by 39.2 gives me the same thing, 0.71. So these guys are similar. So then I've got to walk my triangles. I'm going to go, start at K, walk my small to my large, and then back. And then same thing here. I'm going to start at my small, and go this way, and walk back. So they started at P. They walked P, K, M. So that means I have to start at L. So this is L, Q, M. And that's a triangle. And these guys are similar because I have two sides. And then remember, these are vertical angles. So this is side, angle, side, similarity. All right, this way, again, this is one of those ones where I have a composite triangle. So I have one here, and then I have one here. So now I have two angles, so I need to make sure that my two angles are going to match. So I need to see if this angle right here is 98. So I'm going to take 180 minus 47 minus 38 to see what that angle is. So 180 minus 47 minus 38 is equal to 95. Since these two angles are not the same, these are not similar. All right, let's go down here. Okay, I've got three sides, so this would be side, side, side. So I'm going to find my smallest side, my medium side, my large side. Small, medium, large. We're going to call that one A, we're going to call that one B. And it's always A to B. All right, so I'm going to create my ratios. So I have three sides. So I'm going to start with my small. And then I'm going to go to my medium and then my large. I'm going to do my small, medium, large for my B. Small, medium, and large. Now, since I have a decimal in my fraction, I have to convert all of these to decimals to see if I do have indeed a side, side, side similarity. So 8 divided by 10 is 0.8. 9 divided by 11.25 is 0.8. And 12 divided by 15 is 0.8. So indeed, all of my sides are proportional. So this is by side, side similarity. And they started with R. And they went through Y. So they went medium, large, small. So we gotta do the same thing. We gotta go from small to medium. So that's A, D, E, and this is triangle. So triangle RYN is similar to triangle ADE. All right, 12. Well, I have angles, so the first thing I have to do, since these both have 90 degrees, is I have to calculate the second angle. So I'm going to take 180 minus 33 minus 90. See what that gives me. 180 minus 90 minus 33 gives me 57 degrees. So indeed, I have angle, angle. So these are angle, angle similarity. Now we start with D, or C, go to D and then E. So I'm going towards the 90 degrees angle from the 33 degrees angle. So this is going to be triangle KGH. All right, on to the next page. All right, now we have proofs. With the proofs, remember we have to mark our figure, so it says that EH is parallel to FG. Okay, if those angles are parallel, then I'm going to have corresponding angles. I have one set here, and I have another set here. So we're proving angle, angle similarity. I have two angles. We are good to go. So the first thing we're going to do is put our given down. So we got EH is parallel to FG. That was given. Then it says a set of corresponding angles. All right, well, I'm going to go this way and then down. So I'm going to say angle DEH is congruent to angle DFG. Now remember, kiddos, that this middle one is where your point, your vertex of your angle is. So it should be E and F. E and F. Okay, then it says I got to use the reflexive property. So that means I have to use this angle up here. So I'm going to say angle D is congruent to angle D through the reflexive property. And now I have two angles, so I can say triangle, and then I'm going to just use my angles. DEH is similar to triangle DFG through triangle similarity. And now because my triangles are similar, I can say any sides are proportional or any angles are congruent. So it wanted me to say that DE to DF is equal to EH to FG. And this means corresponding sides of similar triangles are proportional. All right, next one. It's already set up in a ratio, which tells me that I'm going to have to divide, but let's just mark my triangle here. So I've got AC, and then 4 DC, and then I've got BC and EC. Okay, so the first thing we look at is we notice that these can be side, angle, side, because I have a set of vertical angles here. All right, let's get started. This first one, AC is equal to 4 DC. That was given to me. And I might as well go find the other given. We got BC is equal to 4 EC, so I'm going to write given down there. So now, how I get from AC divided by DC equals 4 is I'm going to divide DC from both sides. So this would be AC is equal to 4 DC, and I'm going to divide DC from both sides. And I end up with AC over DC is equal to 4. And that's what's going to happen for number 4. I got BC is equal to 4 EC. Well, I'm going to divide EC out of both sides. When I do that, I've got BC over EC, so this is divide or division. So now, since they're both equal to 4, their ratio is 4, I can now set them equal to each other. And remember, this is the transitive property. And now I'm looking at an angle. So this is BCA, so BCA, and then ECD, ECD. So this is my vertical angle. So now I've shown that two sides are proportional and I have the angle between them. I can claim that these two triangles are similar. So since these two triangles are similar through side, angle, side similarity, that means I can claim any angles are congruent or any sides are proportional since they are similar figures. Since these are angles, I'm going to use corresponding angles of similar triangles are congruent. So I'm using Castic. Right. All right, here we go. So on this one, this says PR. So here's PR and PS. So it's using the ratio between those two side lengths. And then the ratio between QR and QT. So notice that they're using the same side lengths in their ratio. And if those sides are proportional, then I have this angle right here. So then I will have a side angle side similarity, which is what they're going after down here. So the first thing I'm going to do is put my given in here. I got PR is equal to 4 PS and QR is equal to 4 QT. Oh, I noticed down here that they actually use QR, so I will get rid of the second one and write given down here. So just like the last example, all they're doing is dividing PS out from both sides. So this is division. And then here I need to divide QT out from both sides. So I end up with QR over QT is equal to 4. And that's the division property. So now I have both of my ratios are equal to 4. So I can transit through them and use the transitive property where PR over PS is equal to QR over QT. So now I have a set of sides that are proportional. Now they have an angle here, so they're saying angle R is congruent to angle R. And this is my reflexive property. So now, since I have my sides are proportional and my angle, I can now say the triangle is similar. So I'm going to say triangle SRT is similar to triangle PRQ. Remember, we always use what they gave us instead of trying to create our own, so that way it's always true. And now because I have sine, angle, side similarity, that means any angle is congruent. Corresponding angles are congruent, and corresponding sides are proportional. So since these are angles, this is corresponding angles of similar triangles are congruent. All right, last one. We have WY bisects angle XYZ. So that means these two angles are congruent. And then it tells me that XY over YZ, and then WY, so this whole thing here, and VY, so this little guy there. Say those guys are proportional. So looking at this figure, I can tell I'm going to be using side, angle, side again. So we're going to start with what was given to us. We got WY bisects angle XYZ. This was given. So since I have bisect, that means bisect. I'm going to be using the definition of an angle bisector. So I need to walk my figures. So WXY, so WXY, and VZ this way. So then my angle is going to be angle XYW is congruent to angle ZYV. And then I'm going to put my other given in here. So I've got XY over ZY is equal to WY over VY. This was given to me. So now I can say these two triangles. So triangle XYW is similar to triangle ZYV because of side, angle, side similarity. And now I can say any two angles, corresponding angles are congruent and corresponding sides are proportional. So I can say angle WXY is congruent to angle VZY because corresponding angles of similar triangles are congruent.